Welcome to Module 2, Lesson 7. So today we're going to be continuing on with weight. We're going to learn how we can develop estimation strategies by reasoning about weight, specifically with objects. So the idea that we're getting at here is that we are able to recognize that you would or would not measure something in a certain weight. So, just kind of give an example here. We're talking about grams and kilograms. So, grams is a smaller unit. It's itty bitty, teeny tiny. Very, very, very small. Well, a kilogram is larger. It takes 1,000 grams to make 1 kilogram. So, it's conversion. Like 60 minutes make an hour. 1,000 grams makes 1 kilogram. So, just kind of keep that in mind. Now, just kind of give you a visual perspective of how much just a gram would be, just based off of something that you would recognize. Because sometimes a little chip, you're like, I don't know how much that weighs. But an eraser, just a generic eraser like this that you put on into your pencil, weighs roughly 1 gram. It doesn't weigh exactly 1 gram. Just keep that in mind. Not exactly 1 gram. It weighs about 1 gram. Just kind of give an idea of that. While this bag filled with erasers, you can kind of turn around, see how much and how big this is. This is about, remember, not exactly, this is about 1 kilogram. So, as you can see, the size difference is quite a bit. So we can assume that there's about 1,000 more here in this. It doesn't look like it, but there's a lot in there. So, just kind of keep in mind, 1 gram, 1 kilogram. So, and you can measure things in these units. But one is more beneficial to weigh in than the other. So, for an example, if I were to ask, what unit would you want to weigh a car in? Would you want to weigh it in units that are this big? Or would you want to weigh it in the larger unit? The idea is the larger unit. Because if I'm weighing it in this, you technically can. It's just going to be a really big number. Keep that in mind. So it's kind of an example of like 3 hours. If you did 3 hours of homework, which hopefully it's not taking you that long, but you had 3 hours of homework, you could say just 3 hours. Or you could say 180 minutes. Now, those equal the same thing. They mean the same thing. But just to make things smoother, just use the bigger unit. An hour is a larger unit. It takes 3 hours versus 180. Because once you get bigger and bigger and bigger, you can imagine how these numbers can be really, really big. So, example-wise, remember, one of these, or 1,000 of these, weigh a kilogram. So 1 gram, 1 kilogram. Remember that. Now, imagine a car that can weigh, like you have a toy car. I'm not going to use a real car right now. A toy car that weighs 25 kilograms. A decent amount of weight. So 25 of these. Still not too much, but it's a toy car, so just kind of keep that in mind. Toy car made out of 25 of these in its weight. Would I want to say 25 of these, or would I want to say 25,000 of these? Hopefully, you're saying this. It's a smaller unit. There's less chance of making a mistake while using larger units like this. It's kind of like days and years, whatnot, and months. We use those categorizations, so we're not saying, oh, we go, it's December 1st. We don't say it's day 342. We don't do that because it kind of gets confusing. You're like, okay, we're in 2020, the year 2020. We're currently on this day of this month. And so it's taking a big unit, and we're specifying a bit of that unit, and we're specifying even more to the day, and can do that even further to the hour, to the minute, to the second, so on all the way forth. So it kind of builds down from there. Just kind of keep that in mind. And what you can do with these is that you can estimate the weight of things. It's like, so, based off of maybe my water bottle, say it's completely filled, would you want to weigh this in grams or kilograms? Since this isn't a whole lot right here, you might want to measure it in grams, because if you are weighing, if it's less than the kilogram, you might be getting to the point where you're like, okay, it's a half a kilogram, and it's an eighth of a kilogram, a ninth, and it's not one full. It kind of gets confusing. We haven't talked about fractions yet. I don't want to go there. But if I were to say I'm going to measure my car that's out in the parking lot, would you want to weigh it in small grams or do you want to weigh it in a larger number? The number that represents something larger. So you'd want to weigh it in this. You can go examples on this. You can measure, you can be like, okay, I have a pet rabbit. Rabbits, are they very heavy? No. So maybe grams. But how about a pet horse? Kilograms. So on and so forth. Now, to give an example, we have built tools. We have built tools, and I destroy the tools. So let me go ahead and fix this real quick. We have built tools to go ahead and help us identify and measure weight. And we call these scales. Now, I'll fix this a little bit more later, but something like this. This is a spring scale because on the inside of this there's a spring. When you push down on it, it stretches the spring, which then turns this dial. So as this gets pushed down, you can see it goes all the way around. So since this is being measured in, if you look really closely, it says 1 pound, it says 1 kilogram. So it's measuring in a couple different units here. Try to get it close so you can see it a little bit. So it's kind of like a clock. Keep that in mind. You're reading it like you would a clock, going around this direction. So right here is 1 pound. That is 500 grams, so half of a kilogram. 1 kilogram is way down here, where it says 1 kilogram, 2 kilograms, 3 kilograms, 4 grams, all the way around. Now, this scale doesn't do a great job of measuring something this light because it doesn't really recognize it. For those who use digital scales, which are a little bit more accurate on the small numbers. But when you're weighing heavy things, you don't need to worry about it too much in that realm. So, just keep that in mind. Now, that being said, let me stick that back over there without breaking it again. I have drawn a very basic scale that we can use some examples here for. I don't want to use that one right now because I don't have something for it to sit on, and me holding it, pushing down it, there's too many things getting in the way that's not going to get an accurate read, and it's going to be hard to read, etc., etc., etc. And on top of that, this is how you're going to see things on your homework assignment. So I'm going to do it this way. So remember, a scale, you read a scale the same way you read a clock, around this way. But the big difference with this is that the numbers may change on it depending on what unit you were in. So you could have this be going around like this, and this being 1 kilogram, down here being 2 kilograms, 3 kilograms, and then 4 kilograms being at the top. You could have something like that. Or you could have a scale that has a whole bunch of tick marks going around like this, and saying this is 1 kilogram, 2 kilogram, 3 kilogram, all the way around. It just depends on the scale. You need to look at these numbers in order to recognize it. If you don't look at the numbers properly, you're going to get things messed up. So make sure you know what you're looking for. Or you could have this be 500 grams, 1,000 grams, 1,500 grams, 2,000 grams, and going off of this, you could say this is 1 kilogram, 2 kilograms, so on and so forth, and you work yourself around in that direction. So just kind of keep it in mind. Now, I'm going to keep this relatively basic. I'm not going to do anything too crazy, just for the fact that sometimes reading numbers can be a little bit difficult on a screen like this. So I'm going to keep it relatively basic and relatively simple. So I'm going to have a couple tick marks right here, going around. And I'm going to stick with this being 1 kilogram, down here being 2 kilograms, right here being 3 kilograms, and at the top being 4 kilograms. Let's say I went and I got some food for me, my wife, my kid, my mom, my dad, and a couple other people. So we got a lot of food, and I put them all on top of this tray. So we can draw like a box of fries here, like that. You can draw a hamburger, draw a very large hamburger right here with multiple multiple pieces of meat on it. But you get the idea. There's a lot of food on here. There's a lot of weight. Now, let's say after we've done all this, put those together, the hand that is on here is pointing down at this 2 kilograms. And so I could ask you, how much does all my food weigh? You look at the scale and recognize, oh, it's pointing at 2 kilograms, so it's 2 kilograms of food. Just kind of keep that in mind. This is kind of the primary thing that we will be moving into, is being able to recognize and read weight. And there's not really a whole lot more I can do with giving you an example on this. You read it like a clock. Wherever the arrow is pointing is the weight that you have. But instead of having a minute hand and an hour hand, you only have one. You only have one hand, so there's a little bit less work. But the biggest thing you need to do is being able to make sure you recognize what unit are we working in. Because every single scale, or they may or may not, but you need to check, may say or look a little bit different, and you need to know, am I in kilograms or am I in grams? Hey, what is this pointing at? Is it talking about half? So you get the idea. It's making sure you're recognizing what unit you're in and what does your scale look like. Now, you can continue on and ask some questions like this. I'll even use a couple examples from the problem set. So you could do an estimation, and hopefully remember, kilogram is heavy. A gram is very small, very light. So I could ask a question along these lines, which statement is more correct? Would a watermelon weigh about 3 grams, or would a watermelon weigh about 3 kilograms? So would a watermelon weigh about 3 of these? That would be a really small watermelon. Could a watermelon weigh about 3 of these? Yeah, still be a relatively small watermelon, but which one makes more sense? A watermelon weighing 3 of these, or a watermelon weighing 3 of these? That's the answer. So you'd circle that one. Another example is a cat weighs about 4 grams or 4 kilograms. Once again, cat going to weigh 4 of these? Once again, that would be a really small cat. So you'd probably choose something like this. You can continue on by saying, like, maybe a lemon. Just taking a lemon. Like, does a lemon weigh about 58 grams or about 58 kilograms? So 58 of these or about 58 of this. Now, I'll even give this. 58 of these still seems like a decent amount. But 58 of these, that would be an extremely large lemon. So which one is it more reasonable to go with? The smaller one. 58 of these. So that is kind of like the primary thing that we're going off here. With your problem set, it does go into this a little bit more in depth, but after you your Zern lesson, it should go into a lot of depth about it there, and it has some better visual examples than what I can do here. The pictures are cleaner, the pictures are more vibrant, and the explanation of those pictures are very nice because they go with it. I'm not going into too much detail here because this can be confusing with how specific this is getting. Like, to give an example, like one of you can look at your problem set right now. You'll have a problem set where it's like this little box right here. It blows that picture up and says, this is what's in here, and you see a whole bunch of little bit of lines right there with the arrow pointing there and says, what is this point right here? Now, I'm not a machine. My ability to draw that accurately, that smally, not very plausible, let alone you wouldn't really be able to see it that well. So just kind of keep in mind what we're doing here, how it's going, and hopefully this made sense to you guys a little bit, but hope you guys have a great day.